Today, I wanted to talk about motors, single-phase motors. Out in the field with what we do, we run into different types of single-phase motors. So today I wanted to talk about the more common ones. There are 5 of them that I wanted to talk about. The first one I wanted to talk about was the split-phase induction motor. Split-phase induction motor. Then there is the capacitor start induction motor. Then there's the capacitor start, capacitor run induction motor. Then there's what they call a permanent split capacitor motor. And then there's what they call a shaded pole induction motor. Those are the 5 that we typically see out in the field. So let me start off with the split phase induction motor. First of all, anytime we say induction motor, that means that it's generating a magnetic field. And all of these motors, they all generate a magnetic field. So all of these are going to be induction motors because they do generate a magnetic field. So on this split phase, what does that mean? That means that you're going to have still 2 sets of windings. You're going to have power coming in like this. Then you're going to end up having a winding here. And then you're going to have another winding here. This winding is going to be fed by the same line, but what they do is they put a centrifugal switch on there. A centrifugal switch. In one of the other videos, I was saying that centrifugal switches, they usually open at about 75% of the speed of the motor. At about 75% of the speed, they go ahead and open up. Now with these motors, what they have done is that they have put a resistor here before this winding, and on this other one they have put a resistor in this other winding also. From here, both of these are going to go to L2. So single phase because you have 2 hot legs. This will be basically your run winding. This is going to be your start winding. And some people, what they do is they call this your auxiliary winding. So some people refer to it as start or auxiliary winding, whichever, but it's the same thing. On startup, this switch will be closed. The centrifugal switch will be closed. It starts up, and at 75% of the motor speed, that opens up. Once it opens up, it takes the start winding out of the circuit, and it's only going to run on the run winding. On the run winding. So if you notice, this does not have a capacitor. It just has the 2 windings, and they're splitting the phases here, and the centrifugal switch is taking this out of the circuit. So that is the first one that I wanted to talk about. The other one was a capacitor start induction motor. Capacitor start. Just like the name says, it has a capacitor for startup. The name usually tells you what it's all about. So now we again have, let's say, L1 here. It's going to come here and it's going to go to this winding here. Let's say this one here is going to be my run winding. The same line that feeds the run winding is going to feed your capacitor. And then from your capacitor is going to go to the centrifugal switch like this. From here, you're going to have this other winding. This is going to be your start winding, and this could be, let's say, L2. So this will be your start winding. There's your run winding. On startup, this switch will be closed. When the motor gets to about, again, 75% of the motor speed, that centrifugal switch is going to open up. Once it opens up, it takes the capacitor and the winding out of the circuit. It just takes it all completely out. So now we're going to be running only on the run winding again. Only on the run winding. So this would be your split phase induction motor. This would be your capacitor start induction motor. The next one we're going to talk about is your capacitor start, capacitor run induction motor. What they do is they go ahead and they have a run capacitor right here, and that's also feeding the start winding. So now we see that the same line that feeds the run winding feeds your start capacitor, and it feeds your run capacitor. The start capacitor gets taken out at 75% of the motor speed. Your run capacitor is going to stay running as the motor is running. And this is what they use when they need the high torque on startup. A lot of times we see this in refrigeration compressors. When you go to a unit and it's got a little single phase compressor, you might see that it's going to have a capacitor start, capacitor run system set up on it. So we talked about the split phase induction motor, the capacitor start induction motor, capacitor start, capacitor run induction motor, and then there's what they call permanent split capacitor motor. For that, what they do is they have the line that comes in here, feeds the run winding. So let's say this is L1, this is L2, and it really doesn't matter which line feeds the common, which one feeds the run winding. The important thing is that same line that feeds the run winding is going to feed your capacitor. And your capacitor is going to feed your start winding like this. Now if you notice, this one, it does not have a centrifugal switch. This one is going to stay in line and it's going to be running all of the time. So now this is what they call your permanent split capacitor induction motor. Permanent split capacitor induction motor. Because this run capacitor stays in line and the run capacitor feeds your start winding all of the time. Now, one thing that I mentioned before was that same line that feeds the run winding feeds the capacitor feeds the start winding. Here I'm showing that I have a centrifugal switch, but like in one of my other videos, this could also be taken out by the potential relay. The potential relay. We talked about how to wire up the potential relay, which connections to use on the potential relay. So make sure you take a look at that video so you can see how the potential relay would go hook up. Then the last one that we want to talk about is going to be your shaded pole motor. Shaded pole motor, a lot of times this is what you see in, let's say for example, your exhaust fans in a bathroom. Very low torque, and they don't have that much horsepower, they don't have that power behind them. So they use them for small, very, very small fans, and again, it's a shaded pole. What they do is they have the pole on, they have the winding, let's say here, and then they have the pole like this, and what they do is they split that pole up like this, and then on this end, what they do is they put a copper band on it. They put that copper band on there, and that basically gives you another phase. Just like these capacitors, all of these capacitors, what they're going to do is they're going to slow down the current so that you have a phase shift. Well, on these right here, because your rotor is going to be right here like this, and your rotor is going to be rotating, this copper band, what it's going to do is going to slow down the current also, and it's going to give you a phase shift. Once it gives you that phase shift, then we can get this to rotate. So again, we have the split phase induction motor that we talked about. The start winding gets taken out of the circuit at 75% of the motor speed by the centrifugal switch. Then we have the capacitor start induction motor, where we use the capacitor and start capacitor and a centrifugal switch that takes it out of the circuit at 75% of the motor speed. Then we have the capacitor start, capacitor run induction motor, which takes the capacitor out of the circuit at, again, 75% of the motor speed, either by a centrifugal switch or by a potential relay, one of the two. The run capacitor stays in line. Then we have the permanent split capacitor motor here, And what they do with this one, it stays in line the entire time that it's running. The entire time. And this is typically the one that we see out in the field. And like I said, for very low torque applications like exhaust fans and so on for the bathroom, the little tiny fans, they use this shaded pole. But these are basically the motors that you're going to see out in the field. Make sure you check out my other videos because I explain more about the potential relay, the centrifugal switch, the run capacitor, how they go wired, and so on. Again, my name is Julio. I hope this helped. And check my page on Facebook. Make sure you check out Aircon Academy and subscribe to my channel here on YouTube. If you have any questions, just let me know. If you would like me to explain a little bit more about one of these, check out my other videos, or just let me know and I'll see what I can do about getting the videos online for you. Again, thank you.